Alright guys, how's it going? Here is our last note of distance learning and the school year. I know, can you believe it? I find that March had about 200 million days in it, and then it's just been flying by ever since. So yeah, pretty crazy. But yeah, so here's our last note. I'm just gonna go through it. It's not too bad, not long at all. And I'm actually gonna post your assignments probably tomorrow. Actually, I'll say this again, but just so, because marks for me are due next week, so it gives you guys enough time to get it done. Okay. Who knows? Maybe I'll even post it today. Who knows? Okay. So applying trig ratios. So again, quick little review. What does SO stand for? Hopefully by now you guys know exactly what this means. It means that oh my gosh, I'm sorry. Sine theta is equal to opposite over hypotenuse. Yeah. Ka is cos adjacent over hypotenuse. And TOA is tan opposite over adjacent. Okay. So, hopefully you guys are pros in that by now. Remember SOHCAHTOA. So again, that's just the little thing to help you remember what the ratios are. Okay, so line of sight. So this thing's new. Line of sight. So what's going to happen is this is our line of sight. So pretend this is going to look a little creepy, I bet, but that's okay. These are his eyes right here. Near. Actually, that doesn't look as bad. Okay, so this is his line of sight. Let's pretend he has blue eyes. Oops. Okay, so he's looking here. Actually, I'm going to change the direction of his eyes. There we go. Okay, so he's looking this way. Okay, this is the line of sight right there. So we have this thing, there's this thing called angle of elevation. So elevation means the angle that your line of sight makes from the horizontal line when looking up. So if those are his eyes and he's looking this way, okay, the angle of elevation is the angle from when he's from his line of sight and up. Okay, actually I'm going to change that to yellow. I know I'm just being finicky. Okay. So it's the one going up. Where the angle of depression is the sight line and looking down. So again, the same sight line but looking down. Okay, and this does make a difference because depending on the angle itself. So this, we would have got more into this if we were in class. So what would have happened is they would have given us the angle of depression, but we needed the other angle, so we'd have to do a bit more math, but we're not going to get into that. So there is a couple questions here, though, that talks about elevation and depression that we're going to get into. And yeah, so it's not too bad, guys. It's just one thing I wanted to add in because you probably will be looking at it next year in grade 11. Okay? So, first question. While on icy roads, a truck slid into the ditch and hit a light post, breaking it 2.7 meters up the base. Oops. So there's our 2.7 meters. Another thing, too, that I'd usually get you to do if we're in class is draw the image, but again, considering. The top portion of the light post is now touching the ground, as you can see. The angle to which the top of the post made with the ground is 62 degrees. How tall was the light post before it was broken? Okay, so if you can picture this, this is what our triangle would look like right here, right? We've got our 62 degrees. This is our right angle triangle. It says, how tall was the light before it was broken? Well, that means we need to find this guy, right? Because originally it would have been up here. Don't mind my drawing. Yeah, don't ask what that is. Let's just pretend that never happened. But now it's broken, right? So we would have looked at this whole thing, this thing as a whole, right? Okay. So we need to solve for that x. So let's figure out what we have. Let's label. We have our angle. So that means this is adjacent, this is opposite, and this is hypotenuse. So if I do my SOHCAHTOA, I need to solve for my hypotenuse, right? So that means tan's gone. What else do we have? We have our opposite. So we're going to use sine. So cos is gone. So sine theta is equal to opposite over hypotenuse. My theta is 62 degrees. My opposite is 2.7. My hypotenuse is x. So again, because we're solving for a side, we're going to use our fish. So x is equal to 2.7 times 1, right? Divided by sine 62. So 2.7, divided by sine 62. 3. 3.05, so it's technically 3.1. So is that my final answer? Hopefully you're saying no right now. Because it says, how tall was the light post before it was broken? Well, this 3.1 is only that section, right? From here to here. We have to add in that guy. So it has to be 3.1 plus 2.7. So 7, 8. So therefore, the post was 5.8 meters. Okay, so don't forget that. Okay, next one. From a point 8.5 meters from the base of the tree. Okay, so here's the base of the tree. We're 8.5 meters out. The angle of elevation, so again, if this was my line of sight, okay, that's not working as well as I thought. If this was my sight line, this is my angle of elevation, this would have been my angle of depression. Okay? So, just in case, I'm sure you all were wondering. Go away, dots. Okay. So, the angle of elevation to the top of the tree is 36 degrees. Find the height of the tree to the nearest tenth of a meter. So, the elevation stuff, too, is a lot more important when it comes to you guys actually having to draw it. But, as I said, we're not doing that. So, let's take a look. Let's label. We have our adjacent. We have our opposite, and we have our hypotenuse. Let's do our SOHCAHTOA. So we need our opposite. So that means we're using either sine or tan. So see you later, cos. We also have our adjacent. That means we are using tan. Okay, so tan 36 is equal to, what's my opposite? X over 8.5. As you all know, this is over 1. Yeah. So x is equal to 8.5 times tan 36. Technically it's divided by 1, but anything divided by 1 is the same. .17, so 6.2. What does it say? To the nearest tenth of a meter. 6.2. So, what are we finding? We are finding the height of the tree. So the height of the tree is 6.2 meters. Again, guys, this goes without saying, try these before I do them. Pause it. Okay? I find that works really well. It challenges you, right? Because these are the kind of questions you're going to get on your test. So, look at that. 2 more questions, we're done. The highest point along the cliffs in Toronto is 90 meters above the shore. Okay, so this is the cliff. So this is 90 meters. From the top of the cliffs, a surveyor using a 1.5 meter tall transit instrument, so that's this, so this whole thing is 91.5 meters. Spots a boat in the lake at an angle of depression at 42 degrees. So this is where we're surveying from. This is our sight, our line of sight, or our sight line. Remember, if we go up, that's our elevation. If we go down, that's our depression. So that means this is the angle that we're talking about here. Okay? So, how far is the boat from the shore? So, I'm gonna make a triangle. I should do it in red, just so we said that angle is what, 42? Yeah. How far is the boat from the shore? So that's this guy here. Not the distance from the surveyor to the boat to the shore. So now that we have our angle, we know that this is my hypotenuse, this is my opposite, and this is my adjacent. So again, so what do we need? We need our opposite. So it's either sine or tan. And we don't have our hypotenuse, so right away, hopefully you guys are going to be like, well, that's tan. So tan theta is equal to opposite over adjacent. .42 degrees. Oops. What's my opposite? It's x. My adjacent is 91.5. .3, 82.4. Right? Yeah, 82.4. To 1 decimal place. So therefore, the boat 82.4 meters away from the shore. Okay. Okay, so again, super important for you guys to be able to label these properly, because if you labeled this the adjacent and you labeled that the opposite, your answer is going to be incorrect. Okay, last one. So from a point 8 meters from the base of the building, Ross measures the angle of elevation to the top of the building using a 1.5 meter tall transit instrument. Sorry. The angle of elevation is 50 degrees. How tall is the building? So, from 8 meters from the base, okay, so this is 8 meters. He measures the angle of elevation, so here's the sight line, okay? So it's got to be from, so the angle of elevation is 50 degrees. How tall is the building? So, one thing to keep in mind when we're doing this, here's our triangle. So we're only taking into consideration this section of the building. So we'll have to add that in after. Okay? So this guy, I'm just going to move him up here because it's the same length, right? It's not like the surveyor is angled. So what do we got? Here's my angle. Here's my hypotenuse. Lots of tan. It's my opposite. And here is my adjacent. I do find that happens a lot in word problems because a lot of the time, you don't really need the angle part. Like, you don't need the hypotenuse. You need more the distances and the heights. That's just what I've found in my good old days. Oh, so how do I know it's tan? Okay, I need my opposite. And I have my adjacent. Okay, so okay, 50 degrees is equal to opposite over adjacent. .53, so 9.5. How tall is the building to one decimal place? So remember, we have to add in that 1.5 meters. So we're going to do 9.5 plus 1.5. How do I know that's 1.5 meters? Because it's right here. Meow. Is equal to 11 meters. So, therefore, the height of the building is 11 meters. Voila. Not that bad, eh, guys? Okay, enjoy. I'm going to post the assignment, and yeah, it's been a slice. I wish we had... Sorry, I'm not feeling well. I wish we had more of a year together, but, you know, crazy times. Okay.